We're now going to look at the potential energy functions graphically, and we have a short but very important page of notes. So we start by just reminding ourselves of where potential energy and work are connected, how they're connected, and we start here with the value, meaning the joule value of the potential energy is given by the mathematical function that is used to calculate the work done by a conservative force. Now, to remind you, specifically, the mathematical equation that defines potential energy is given by the change in potential energy, 3 equal signs equals negative the work done by a conservative force, and we have two conservative forces in mechanics that we are dealing with, the spring and gravity, and both of these equations should look familiar based on our delta U equals negative the work done that I have here in blue. The only difference is that we are now taking the negative over the other side of the equal sign, so work equals negative delta 1/2 kx squared and mgy, and that of course then is where our potential energy functions come from, the mgy and the 1/2 kx squared. Now, the graphical representations are shown here. So the 1/2 kx squared is a quadratic. So that is why this one is drawn as the quadratic, and the mgy is linear. Now, the most important thing that you walk away with from this page of notes is this notion of the analogy between a marble rolling on these potential energy functions and the actual system that they describe. So I'm going to explode this one. Please make sure that you get this into your notes, because this little trick works for all potential energy functions, not just these two. Now, the language that you might see in a question where this analogy will help you answer it would be to take a potential energy function, let's say the u of x, let's use the spring one here, and let's say you didn't know it went with a block on a spring. So you were just told this is the potential energy function, and the language they will use, this is the potential energy function that governs the motion of a particle. So describe in words how this potential energy function governs the motion of a particle if the particle is placed down at a position on the x-axis, and then go. You're to describe how that function will affect the motion of the particle. Well, that potential energy function will affect the motion of the particle the same way that it affects a marble rolling along the actual function. So the object itself begins to speed up to the left, and look, we have the actual mass on the spring will begin to speed up and go to the left. Pretty cool. It will have its maximum speed right as it passes through x equals 0, just like the marble will have the maximum speed at the bottom of this little trough, and then the marble will roll up and come to a stop, and look, just like the mass on the spring, it will stop symmetrically at the negative x max position over here. So negative x, not very neat, but negative x max position, just like the block on the spring would stop here. So believe it or not, this trick works for all potential energy functions, whether it's these or whether it's a nuclear physics class or whatever potential energy function you are given. So some other language that we might see. The other language that you might see would be whether the potential energy function bounds the motion of the particle, or is the particle's motion unbounded. Now, for the quadratic, the spring, this particle's motion is bounded. So even if I didn't know that this was the actual thing going on that was doing the moving, I'm just told that this is the potential energy function that governs the motion, if you place the object down here at position x equals plus a on the x-axis, just from that potential energy function, I know the motion of this particle is bounded. It's bounded between plus a and minus a, and I know it's also oscillatory motion because that marble is going to roll back and forth, back and forth. I know where it has its maximum speed. It's just a really powerful technique. So please make sure you get down all of the annotations that are here. The marble analogy, as I said, works for all systems, so it works over here for taking a particle. Even if I don't know that gravity is going on here, I'm just told this is the potential energy function. Put the marble down, let it roll, it's going to speed up. Going to the left, it's going to have its maximum speed here at the bottom, and that would be right at 0, ground level. So if h represents a height up in the air, it's going to have its maximum speed at ground level when it impacts the ground. So we will be doing more with this. You're going to be getting practice looking at some functions and describing the motion using this marble analogy. But I wanted to get it explained at this point in the notes, even though we'll be doing more with it a little bit later into the notes.